to the next module of this chapter. Now today in this module we would be learning about formation of urine and we would study what is selective reabsorption. Now in the previous module we have studied that formation of urine occurs in 3 stages. The first stage is called as ultrafiltration. The second stage is called as selective reabsorption and the last stage is called as the tubular secretion. So we have already studied what is ultrafiltration and the filtrate obtained after ultrafiltration is called as primary urine. And next process would be selective reabsorption and after tubular secretion we'll get our final filtrate which is called as secondary urine or final urine. Now let's start with what is selective reabsorption. Now please concentrate on this beautiful diagram here. What you can see, as the first step ultrafiltration occurs, what happens? Very important useful substances along with the waste molecules are getting filtered out of the glomerulus. Now in this filtrate which is called as glomerular filtrate, there are very important useful substances which are needed to be absorbed back inside the blood capillaries. So as the name suggests, selective reabsorption. Now we can't afford to lose the important useful substances to get excreted out inside the urine. So what happens here? There is a reabsorption of useful substances from the glomerular filtrate back into the peritubular capillaries. Now this is called as selective reabsorption because we are selectively absorbing only important useful substances. Now this selective reabsorption occurs in 2 ways and it depends upon the concentration gradient of the important or the useful substances. Now if the important substances are moving from high concentration gradient to the low concentration gradient into the blood capillaries, this transport or this reabsorption is called as passive transport or osmosis if there is absorption of water. Now here the absorption is along the concentration gradient from high concentration to low concentration and where there is no requirement of any energy. The other type of selective reabsorption is called as the opposite of passive transport. Yes, that is active transport. Now here there is absorption of useful substances from low concentration gradient to high concentration gradient. Now here there is movement of substances against the concentration gradients. That's why active transport requires energy which is in the form of ATP. So these are the 2 types of absorption methods in selective reabsorption, that is passive transport and active transport. Now if you carefully observe this diagram, now we'll see what are those substances being reabsorbed back from the glomerular filtrate. Firstly, the very important substance, that is glucose. Glucose is the main source of energy. So can we afford to lose it? No, we have to reabsorb it back. Along with that, amino acids. Next, sodium, potassium, calcium, bicarbonate ions and chloride ions. These all elements are very useful and important substances. So these all substances are being actively reabsorbed back through the PCT back into the blood capillaries. Now similarly, there is also absorption of potassium and chloride ion from the distal convoluted tubule. But here this absorption is via passive transport. So potassium and chloride ions are absorbed passively from the DCT. Now let's see how is water absorbed and from where the water is absorbed. Now firstly, from the PCT the water is absorbed along from the descending limb of loop of Henle, then from the DCT as well. So at these places the water is absorbed and it is reabsorbed via osmosis. Now this absorption of water from the PCT, from the descending limb of loop of Henle and from the DCT, this absorption is a compulsory absorption of water from these locations. That's why this reabsorption of water is called as obligatory reabsorption. And if you notice carefully, my friends, the water is not absorbed from the ascending limb of loop of Henle. Now there are certain substances which are completely reabsorbed back into the peritubular capillaries. These substances are called as high threshold substances which are needed to be completely reabsorbed, such as glucose and amino acids. And certain substances which are absorbed at a very small extent, these substances are called as low threshold substances. Examples, urea and uric acid. Now urea is reabsorbed back because it is a very small molecule and it is partially permeable to the renal tubule. So that's why urea is being reabsorbed. Now, if you talk about the reabsorption of important useful substances, now there is a particular limit of reabsorbing this useful substances. Now, if this useful substances goes beyond a certain limit, so it can't be reabsorbed back inside your body. So every useful substance has a particular limit or a particular level in the blood. So that is called as the transport maximum or renal threshold. So kidney's maximum capacity for reabsorption of any substance is called as transport maximum or renal threshold. Beyond this limit, the useful substance wouldn't be reabsorbed back inside the blood. Now take the example of glucose. Now glucose normal blood sugar level is 45 to 95 milligram per 100 ml of blood. Now, any value ranging between 45 to 95 can be easily reabsorbed back inside the body. But the maximum limit of glucose is 160 milligram per 100 ml of blood. Now, any sugar value or glucose value reaching beyond 160 milligram wouldn't be reabsorbed back inside the blood. So that glucose would appear in the urine. So the excess of the glucose is excreted out, and that condition is called as glucoseuria, and this is seen in a disease called as diabetes mellitus. So this was all for this module, my friends, where we studied selective reabsorption. In the next module we will study about tubular secretion.